Radio communication and aviation. Much of aviation communication and navigation is accomplished through the use of radio waves. A radio wave is invisible to the human eye. It is electromagnetic in nature and part of the electronic spectrum of wave activity. In aviation, a variety of radio waves are used for communication. That includes the range of common aviation radio frequencies and their applications. A wide range of frequencies are used from low frequency at 10 kHz to super high frequencies at nearly 10 GHz. To transmit radio waves, an AC generator is placed at the midpoint of an antenna. As AC current builds up and collapses in the antenna, a magnetic field also builds up and collapses around it. Because of the speed of the AC, the electromagnetic fields and electric fields created around the antenna do not have time to completely collapse as the AC cycles. Each new current flow creates new fields around the antenna that force the not totally collapsed fields from the previous AC cycle out into space. Types of radio waves. Radio waves from different frequencies have unique characteristics as they propagate through the atmosphere. Very low frequency and medium frequency waves have relatively long wavelengths and use correspondingly long antennas. Ranging from 3 kHz to 3 MHz are known as ground waves or surface waves. This is because they follow the curvature of the Earth as they travel from the broadcast antenna to the receiving antenna. Ground waves are particularly useful for long-distance transmission. High-frequency radio waves travel in a straight line and do not curve to follow the Earth's surface. This would limit transmission from the broadcast antenna to receiving antenna only in the line of sight. The frequency range is between 2 and 25 MHz. These kind of radio waves are also known as skywaves. Above high-frequency transmission, radio waves are known as space waves. They are only capable of line-of-sight transmission. Most of aviation communication and navigational aids operate with space waves. This includes VHF 30 to 300 MHz, UHF 300 MHz to 3 GHz, and super high frequency 3 GHz to 30 GHz. VHF communication radios are the primary communication radios in aviation. They operate in the frequency range from 118 MHz to 136.975 MHz, 727 distinct channels. VHF radios are for communication between aircraft and air traffic controller, as well as air-to-air communication between aircraft. Loading information onto radio waves. The basic radio wave is known as a carrier wave. To transmit and receive useful information, this wave is altered or modulated by an information signal. The information signal contains the unique voice or data information desired to be conveyed. Two common methods of modulating carrier waves are amplitude modulation and frequency modulation. Amplitude modulation, or AM. A radio wave can be altered to carry useful information by modulating the amplitude of the wave. However, AM has limited fidelity. Atmospheric noise or static alter the amplitude of the carrier wave, making it difficult to separate the intended amplitude modulation caused by the information signal and that which is caused by static. It is used in VHF communication radios. Frequency modulation, or FM. Frequency modulation is widely considered to be superior to AM for carrying and deciphering information on radio waves. The information signal alters the frequency of the carrier wave in proportion to the strength of the signal. FM bandwidth is greater than AM bandwidth. This is overshadowed by the ease of which noise and static can be removed from an FM signal. FM has a steady current flow and requires less power to produce. Single sideband communication. In radio communication, single sideband modulation, or SSB, is a type of modulation used to transmit information such as audio signal by radio waves. A refinement of amplitude modulation, it uses transmitter power and bandwidth more efficiently. Amplitude modulation produces an output signal, the bandwidth of which is twice the maximum frequency of the original baseband signal. Signal sideband modulation avoids the bandwidth increase and the power wasted on a carrier wave, as cost of the increased device complexity and more difficult tuning the receiver. Many high-frequency long-distance aviation communications are SSB. Transmitters. A transmitter consists of a precise oscillating circuit or an oscillator that creates an AC circuit wave frequency. This is combined with amplification circuits or amplifiers. Other circuits are used in the transmitter to accept input signal and process it for loading onto the carrier wave. Modulator circuits modify the carrier wave with the process information signal. A transmitter prepares and sends signals to an antenna that radiates the waves out into the atmosphere. A transmitter with multiple channel capability contains tuning circuitry that enables the user to select the frequency upon which to broadcast. This adjusts the oscillator output to the precise frequency desired. Receivers. Antennas are simply conductors of length proportional to the wavelength of the oscillated frequency put out by the transmitter. An antenna captures the desired carrier wave as well as many other radio waves that are present in the atmosphere. A receiver is needed to isolate the desired carrier wave with its information. It is prepared for output to a device such as speakers or a display screen. The output information signal is originally introduced into the transmitter. Transceivers. A transceiver is a communication radio that transmits and receives. The same frequency is used for both. The push-to-talk switch blocks the receiving circuitry and allows the transmitter circuitry to be activated. This saves space and the number of components used. Transceivers are half-duplex systems where communication can occur in both directions, but only one party can talk while the other must listen. VHF aircraft communication radios are usually transceivers. Antennas. Antennas are conductors that are used to transmit and receive radio frequency waves. Although the airframe technician has limited duties in relation to maintaining and repairing avionics, it is the responsibility of the technician to install, inspect, and repair and maintain aircraft radio antennas. Three characteristics are a major concern when considering antennas: length, polarization, and directivity. The exact shape and material of which the antenna is made can alter the transmitting and receiving characteristics. Length of the antenna. When an AC signal is applied to an antenna, it has a certain frequency. There is a corresponding wavelength for that frequency. An antenna that is half the wavelength of the corresponding AC frequency is able to allow full voltage and full current flow for the positive phase of the AC signal in one direction. The negative phase of the full AC sine wave is accommodated by the voltage and the current simply by changing the direction of the conductor. Thus, the AC frequency flows through the entire wavelength. This produces the strongest signal radiated. Most radios, especially communication radios, use the same antenna for transmitting and receiving. VHF radio frequencies used by aircraft communication radios are 118 to 136.975 MHz. The corresponding half wavelengths for these frequencies are 3.96 and 3.44 feet. Antennas 1/4 the length of the transmitted frequency are often used. This is possible because when mounted on a metal fuselage, the ground plate is formed with the fuselage and acts as the missing 1/4 length of the half wavelength antenna. Polarization. Antennas are polarized. They radiate and receive in certain patterns and directions. Receiving antennas with the same polarization as the transmitting antenna generate the strongest signal. A vertically positioned antenna is mounted up and down. To receive the strongest signal from these waves, the receiving antenna should also be positioned vertically. Many vertical and horizontal antennas on an aircraft are mounted at a slight off-plane angle. This allows antennas to receive a weak signal rather than no signal at all when the polarization from the receiving antenna is not identical to the transmitting antenna. Types of antennas. There are three basic types of antennas used in aviation: dipole antenna, Marconi antenna, and loop antenna. A common dipole antenna is the V-shaped VHF navigation antenna, known as VOR antenna. Each arm of the V is 1/4 the wavelength, creating a half wavelength antenna which is fed in the center. Marconi antenna. A Marconi antenna is a 1/4 wave antenna. It achieves efficiency of a half wavelength antenna by mounting to the surface of a conductive skin fuselage to create the second 1/4 wavelength. Most VHF communication antennas are Marconi antennas. On fabric-skinned aircraft, the ground plate that makes up the second 1/4 wavelength of the antenna must be fashioned underneath the skin. Loop antennas. The third type of antenna commonly found in aviation is the loop antenna, when the wavelength of an antenna conductor is fashioned into a loop. Used as a receiving antenna, the loop antenna properties are highly direction sensitive. A radio wave intersecting the loop directly broadside causes an equal flow current in the both sides of the loop. However, the polarity of the current flow is opposite of each other. This causes them to cancel out and produce no signal. When a radio wave strikes the loop antenna in line with the plane of the loop, current is generated. The phase difference of the generated current proportionally to the angle at which the audio wave strikes the antenna. This is useful in automatic direction finder navigational aids.